7.7, we're going to be solving equations involving inverse trig functions. So example 1 is supposed to be a basic example, and it says solve. Anytime it says solve, it's going to be talking about isolating a variable. Okay, so we want to isolate the variable, but in this case, they tell you exactly which variable to isolate. Solve for x means isolate x. So you need to know that. Solve for x means isolate x. Hopefully you already do know that because you all passed out for 1. So I'm looking at this equation and I'm trying to isolate x. So I will focus on x. You don't need to circle it, but you need to look at it and just see what's happening to x. There are some different things that are happening to x. I need to peel this onion, right? Peeling an onion, I'm taking off layers, and you have to take off the outermost layer. So if I'm going to get this x by itself, the first thing I'm going to have to do is divide both sides by 3. Divide by 3 to cancel out that 3. And so what you're looking at is y over 3 equals cosine 2x. I'm peeling that onion. We want to get what x is. We're going to have to get rid of that cosine. And so we know to get rid of the cosine, we're going to do an inverse cosine. So let's do inverse cosine on both sides. Inverse cosine of cosine 2x is going to just be 2x. So what we have is inverse cosine of y over 3 equals 2x. I would use parentheses around that y over 3 just to be super clear about what's going on. Okay. So if I want to get x, the last thing I'm going to have to do here is divide by 2. I divide by 2 to get x by itself. And so at this point you can see that x is going to equal, it's not really standard to have a fraction on top of a fraction. So instead of saying divided by 2, I'm going to say 1/2 times. 1/2 times inverse cosine of y over 3. 1/2 times inverse cosine of y over 3. That's it. Solve for x, isolate x, got it. So let's look at number 2, says solve. So again, we're isolating a variable. This one is a little bit different because it doesn't have a y in it, but we're still solving, so we're trying to isolate the variable. So there's your variable x. We're trying to isolate that x, and we need to peel the onion. So can you see what the first move is going to be? Divide by 2. Now, I don't know if you're like me, but if you're like me, this arc sine is a little bit confusing. If you want to rewrite that as inverse sine, be my guest. I think we're all probably more comfortable with that term, inverse sine and arc sine. But either way, if we're going to peel this onion, if we're going to solve for x, the first thing we're going to do is divide by 2. So inverse sine of x equals pi over 2. If I want to isolate x, I have to get rid of this inverse sine. What's going to do that? Sine. Good. Let's take sine of both sides. Sine of inverse sine of x is just x. So x is going to equal whatever sine pi over 2 is. So we have sine pi over 2. Sine pi over 2, straight from the chart, equals 1. X equals 1. You know, and if you imagine the circle, here's pi over 2 up here, this angle, 90 degrees. We look at the point, the coordinates are 0, 1, and we know that sine is talking about the y coordinate of that point. And so there's your 1 right there. Y equals 1. I mean, x equals 1. Example 3, we're still trying to solve. So we know we're trying to isolate the variable. We're isolating this variable. We're peeling the onion. We're going to have to take a cosine of both sides, basically, to isolate x. So that's what we'll do. We'll take cosine of both sides. But if you notice, inverse sine of 1/2, that's going to be a value. There's all numbers there, and so we could evaluate that or simplify that. Inverse sine of 1/2. Anybody know what that is? Inverse sine is defined from negative pi over 2 to positive pi over 2. That is in quadrant 1 and quadrant 2. What'd you say? Negative pi over 2. There's no negative in the problem. It's not negative 1/2, it's positive 1/2. And when it's a positive value like this, we don't even really have to think, it's just pi over 6. Okay? We don't have to think about reference angles or anything that much. We just know it's positive, it's just going to be whatever that reference angle is, pi over 6. So inverse cosine of x equals pi over 6. And so if I'm trying to solve, I'm trying to isolate, I'm going to do a cosine on both sides to knock out that inverse cosine. I would have x equals whatever cosine pi over 6 is.
Square root of 3 over 2.
Square root of 3 over 15, that's right. X equals square root of 3 over 2. Okay, so I want to show you another example that's a little bit more complicated than this, just to try and set up example 4. So copy that down real quick. I've got inverse sine of x minus inverse cosine of negative square root of 3 over 2 equals negative pi. Okay. If we're trying to solve this, we know we're trying to isolate this variable. That's the only one. But what I would do first is I would evaluate this part. Okay. Let's evaluate that. That's all numbers, so we should be able to simplify that a little bit. Inverse cosine of negative square root of 3 over 2. So you're looking at your chart, and somebody says negative pi over 3. But remember, okay, remember for cosine, or inverse cosine, is defined from 0 to pi. And so when you look at that range, you should notice that we're not allowed to have a negative answer.
Pi over 6.
Pi over 6? Okay. It's definitely not negative, though. Okay? It's pi over 6 where inverse cosine is negative. And if you think about it, if we're defining from 0 to pi, we're talking about quadrants 1 and 2 only. And so quadrant 2 is where we would be negative. Inverse cosine can be negative in quadrant 2. And so the way you translate that is this is a pi over 6 reference angle in the second quadrant. Don't say negative pi over 6 because we're not allowed to have a negative value there. So pi over 6 in the second quadrant, we call this 6 pi over 6. So that means that this value must be 5 pi over 6. So let's just bring down the rest of the equation. Inverse sine of x minus that 5 pi over 6 that we just found the value of equals negative pi. So, I'm going to have to do a sine of both sides, but we better add that 5 pi over 6 over first. Okay? Let's add 5 pi over 6 to both sides. So inverse sine of x equals what we would get when we add those. Well, let's get a common denominator. Negative pi would be the same thing as negative 6 pi over 6. When we add that 5 pi over 6, that's going to be negative pi over 6. Inverse sine of x equals negative pi over 6. We're still peeling the onion, right? We're still trying to isolate x. And so isolate x here, we're going to take sine both sides. That means x equals sine negative pi over 6. Now, there are a couple of ways to think about this problem. We've done this before. It's been a while. We've done this before. I think the best way of thinking about it is to remember one of your negative angle identities. Since sine is an odd function, basically we can pull that negative out first. And so I think the best way of looking at this is to understand that this is going to be the opposite of sine pi over 6. So all I have to do is look at sine pi over 6 and throw a negative in front of it. That's what it's got. Sine pi over 6, 1/2. I'm going to have negative 1/2. X equals negative 1/2. Of course, we could always check our answer by plugging it in. The other way, I mentioned there were a couple of ways of thinking about it. The other way, I guess, I would look at this. Maybe you're like, well, negative pi over 6 is going to be down there. If I go around backwards. And so we know that's in the fourth quadrant, making this value negative. And so you can just look at sine pi over 6 and understand the fourth quadrant is going to be negative. So sine pi over 6 in the fourth quadrant is going to be -1/2. Same thing.